Traditional security tools often do not integrate well into developer workflows. One way to attempt to improve this is to provide remediation guidance to developers. At SemGrep, we already have a text-based autofix, and it works great. I've made videos about this before, you can check it out. I love this feature and I'm a big believer. However, there are some limitations to text-based autofix. This is why our program analysis team has been developing an AST or Abstract Syntax Tree based autofix. It is already available for Python and JavaScript, and so in this video we'll explore together what the limitations are about text-based autofix by creating a rule with this new AST-based autofix. SemGrep has many great features to allow us to capture complex patterns in the code. One of these great features is ellipses or ... 3 dots. Ellipses can capture an unspecified amount of code. For example, in a function call, they can capture an unspecified number of arguments. We are going to look at the ruml.yaml parser. We can import ruml.yaml. YAML in all cases is the class. So if you do a class instantiation for this parser, we can have no arguments, or we can specify a type, or there are other arguments. So these are all optional arguments. If we use insecure settings for this YAML parser, this can result in insecure object deserialization. So we want to make sure that we are using a secure YAML parser. Luckily, the default parser in the ruml.yaml parsing is actually secure. It is the type RT, and this is a direct derivative of the safe parser. So in our rule, we are going to look for all other types that are being specified. Our rule looks like this. We are looking for instance creations of the ruml.yaml class where type unsafe or type base are being specified. Now, as you can see, we are using ellipses to capture any other optional arguments that might come before or after the type argument. This is great. However, if you want to write a fix, we need to be able to capture these and reuse them. This we can do with metavariable ellipses. We can turn these ellipses into metavariables. We do this by preceding them with a $sign and appending a name to them afterwards. So these are the arguments that come before our specific type declaration. And then we also have arguments that come after. Now we can reuse them in our fix. It would look like this. And of course, we want to remove the type. And this is what the fix will look like. The thing about ellipses is that they can also capture nothing. So it's possible that this before or after metavariable ellipses is actually just empty, an empty string. If we replace this with an empty string, you'll see that the text-based autofix would write 1 comma too much. This would not result in valid code. SemGrep's solution to this is to manipulate code in the abstract syntax tree instead of in the text. First, it will parse the fix pattern into an abstract syntax tree. In this case, we have an object instantiation, which consists of a class name and some arguments. The class name is YAML, and the argument list consists of 2 arguments, each of our metavariable ellipses, so before and after. In the next step, the metavariables are replaced with their actual values as captured by SemGrep, and if one or both of these are empty lists, then the AST will show the correct amount of arguments. In the case that both of these are empty lists, then no arguments will be printed and we don't need to add any commas. This should result in a correct fix in all of our test cases. Let's have a look. You can see that we are always having the correct number of commas in our test cases. So yeah, that's our rule finished. Do you like the autofix feature? Are there any use cases where you've run into limitation with text-based autofix? And have you tried the AST-based autofix yet? If you like this video, also check out my other video about autofix, where I'll teach you how to write an autofix and test it as well. In that video, I'll also teach you some things about getting around limitations of text-based autofix for the languages where AST-based autofix is not yet available.